So in question 2, we are given two functions and we're given input values for those functions, and we're asked to evaluate what the output value is, what value they produce. So for this first function, I'm going to go ahead and take this input of 3, and that's going to be the value of x that gets substituted in. So I like to write this real precisely. I'm going to write 3 and then open parentheses 3. That's my x value that just went in. Right, this is my input. So 3 times 3 and then plus the value of 2. Well, 3 times 3 is 9, and 9 plus 2 yields a value of 11. So my output here is the number 11. That's part A. For part B, you can see I'm going to take this value of negative 2, and it's going to go in for x. And then that value of x is going to get squared. So notice how I use parentheses here. It's really important to see this distinction. So here's negative 2, right? That's my x value, and I am now going to square that. And then once I'm done with that, I'm going to add 5 to the result. Negative 2 squared, right, is negative 2 times negative 2, which is positive 4. And then when I add 5 to that, I do get the number 9. So this one has a correct answer of 9. One of the things that is a concern is if you write, for example, negative 2 squared, and then below that you write positive 4, it's actually not true. You made a mistake in notation here. This is not what's happening, right? We're not taking the opposite of 2 squared. We are squaring all of x, and x is negative 2. So it's important that you see that this is what's happening. We are squaring all of x, which is negative 2. And this down below here, what we're doing is we're taking the opposite of 2 and squaring it. So the correct value for this, for negative 2 to the second power, should be negative 4. So if you wrote this and below you wrote a plus 4, I may have taken off a point. I think this was worth 3 or 4 points. I may have deducted a point because it's really important that you understand the difference in the notation and that you actually have the notation wrong. So anyways, the correct answer is 9. Whenever you're squaring a variable like this, I highly recommend that you use parentheses, and actually it's a good idea to use them anytime you're substituting in a value. We're going to go ahead and I'll do question 3 at the same time with this video. So in question 3, right, the output of this function, right, if I give it some value x, it produces an output of 12. So here's the thing I'm looking at. 12 is the output. Or in other words, I can say that this function 4x, 4 times the quantity rather of 2x minus 5 is 12. So when we see this, probably the best thing to write down would be that I want to know what value x has to be in order for 4 times the quantity of 2x minus 5 to produce a value of 12. So I'm solving this equation. And actually, while I'm here, let's set up the other one so that we can get both of these set up, right? I want to know when 4x minus 6 produces a value of 6. So what I'm basically doing here is I'm solving for the x that will make, in this case, a 12 come out, and over here, in this case, I want to know what value of x will make 4x minus 6 equal to 6. So once we've got that notation squared away, it's not particularly difficult. There could be some problems with the distributive property, but this is equivalent to 8x minus 20, and that equals 12. If I notice I did multiply both the 2 and the negative 5 times 4. If I add 20 to both sides, we have that 8x is equal to 32. And if I divide both sides by 8, we get that x is 4. So if I come in here and check this, 2 times 4 is 8. 8 minus 5 is 3. That's what the parentheses are. This all becomes the number 3. And then 3 times this 4 is 12. So it definitely checks. For A, x is 4. For B, I'm going to solve this by adding 6 to both sides. So this gives me 4x is equal to 12, and I'll divide both sides by 4. That gives me that x is the number 3. So when x is a 3, 4 times 3 is 12, and 12 minus 6 is indeed 6. So x equals 3 is the correct input value there that would produce an output of 6.